Hello, and welcome to today's video. So on the workbench today is a Solectria BC3000. Normally I do the serial number. Well, I guess I can kind of come around a corner here. This one's got a ginormously long serial number. It's serial number 099-022-351-074. Why it's got that big of a serial number, I have no idea. Normally they're just 3 or 4 digits long. But this guy's in for repair. Customer plugged it in and made a really big boom. And you can see on the power cord here, a big chunk got taken out of one of the pins there. So he definitely passed a lot of current. It obliterated the fuse in it. The customer has had a go at it. They took it apart, kind of boogered up the case a lot. I'll have to see if I can't bend that all back. There's a bunch of screws that go around the edge to hold this on, but there's 2 more. There's a nut that goes here and a screw that goes here that holds the case on from the inside. So that's where the nut is right there. So without removing those, you'll never get the case off. So a lot of prying and prodding until they figured that out. So anybody that's taking apart one of these, just remember to always take those 2 out as well. The 2 corner ones here. Otherwise the case doesn't come off. So what we've got here is somehow we obliterated the fuse. Like there's a fuse that's supposed to go across here, a little wire one, and it's gone. I guess it's a glass ceramic fuse that goes across there. That's blown up. I don't know if you can see on the camera there, but the resistor lead here on this resistor is obliterated. It's gone too. So he's just kind of floating on the breeze. I'll have to replace that. I don't know where that circuit goes. Hopefully it's not something sensing because it got exposed to high voltage. We come in through here through AC, and then we go through that fuse over to here. We go underneath, I believe over to this other side because AC is, I'm cheating because I'm looking, AC is this corner, and then we have positive and negative. You can kind of see the little signs there. And this guy is no longer a bridge rectifier. So if I go ahead and measure here, if I can get on there. So it's dead. Can I get that one? Yeah, see it's dead. So that's no longer a bridge rectifier, so that's definitely a problem. We've got a mauve here, and I don't know how well it shows up on the video, but the mauve is, yeah, you can kind of see it's cracked across the top, so we know that's been exposed to too high voltage, it's dead. And then the more worrisome part is there's a chunk missing out of these. These are a current sense resistor. Essentially, they've got 3 of these. I believe they say 27 on them, so I believe they're 27 milliohms each in parallel there. And one's got a huge chunk out of it, so it's definitely not going to be measuring 27 milliohms anymore. I have no idea how I'm going to find that and replace it. I'm going to have to look around and see if I can't find a replacement for that. This is the main negative going off. So this is the, you can see the little minus sign there, and then the positive sign up here. So positive rail goes over this way, and then the negative rail comes here. But I was trying to figure out what arc to this, because these leads look fine, even though the lighting that's just got some crud on there. Those look fine, and even though this is cracked, it didn't blow out the side and arc to it. They'd be at the same potential anyway. So trying to figure out where that happened, and so I started looking at the case. There's no damage to the case or anything. Then I noticed this. Somebody's put some electrical tape over this wire, and this is the main AC in, or is these 2 wires coming in. So normally those guys plug in right here, right? So my guess is that that wire was touching over here and it eventually cut through. Because it's AC and this is the main negative, it dead shorted across the bridge, would have obliterated the fuse, and then this just died collateral damage from an arc. You know, hopefully that's not sensing anything and that not protected, because that whole circuit might be blown out too. So that's what it looks like happened, because I always like to know the failure mode, because this didn't make any sense to me how this could be this blown open with no evidence of it on the board having died. So I think that's definitely what happened. And the customer went and found this was open, put some electrical tape on it. So I believe we need to replace this, replace this, replace this, replace this guy, and I'll, of course, put a new fuse in. And we'll see what she does. I'm going to have to take it apart to unsolder all of this, which is, and I might be able to do it without taking it out. I don't know all the screws and everything. But this is a battery charger. This is a big planar transformer. I've never seen it. This is actually a giant circuit board. It's really thick, and who knows how many layers are in there. It's probably like something probably in the 30 range. I don't know how many turns are in it. Planar transformer, and I believe this is, we've got some caps here, so this is probably a zero crossing power converter. The actual logic board, control board is here, runs along the edge, that does all the switching, and then there's little connectors down here to go off to all the MOSFETs. The MOSFETs would be under here, or maybe they're IGBTs, I'm not sure, probably IGBTs. They'll be situated underneath here. You can kind of see this big power trace coming out would be coming off of one of those. You can see there the pins here, right? They're laying across this direction. So yeah, that's what's going on there. So anyways, just a quick update, and I'm going to see if we can't unsolder this and take this out without, I'd really not like to take this board off because it's, I don't know how many, it's bolted in by a lot. But anyways, yeah, thanks for watching. Bye.